सबको नमस्ते. Today we will make a project cat and dog classification using TensorFlow, Flask for the web app, and the Pandas data stream. Basically, it going to be a nice project which can sign your resume. So let's start it. First we will preview our project. For this, I want to run this app.py file. Let me run it. After running this app.py file, you will get this link. You have to click on this link. Click. After clicking it, you will get the that browser will get open. See, so this is our interface of web app using a Flask. Let me choose one image. I want to choose this one. Open. See, it display the result dog, and it is 95% surety that the particular image belongs to a dog. Let me choose one another image for the cat. Let me choose this one. See, it is 87% surety that the particular image belongs to a cat. Let me choose one other image for the cat himself. Let me choose this one. See, 95% surety that a particular image belongs to a cat. So, we will going to make this project using the Flask for the web app, TensorFlow as a framework, and Pandas data frame for the training purposes. Let's begin our project. So here, this is an directory where we will code for our training and making a model of cat and dog classification. This is a database containing two folder, train and test. In train, we have a cat and dog images containing their name, cat4 like this, and same for the dog. I will show you. See, same for the dog naming. Now we will code. Now we will code for the training. Let me open this in VS Code. So this is our Jupyter file for creating a CNN architecture and for the training purposes. This is the first cell. If you will run this Jupyter file in your Google Drive, you have to run this to connect your Google Drive. If your data set in a Google Drive, you have to run this. Changes this file path where the data set is there. Otherwise, if the connection is not successful, you have to run this just in case you do not have a dataset zip file in your Google Drive. These are the libraries which we used to make a CNN model and for the plotting purposes and for the competition also. So I will explain you what is the meaning of each and every library and below code when we code for the CNN model. Let me run this cell. After this, the second cell is no, not second cell. Fourth cell is this. Basically, it is the image dimension which we use which we use as an input for the first convolution layer. There is three channel: red, green, and blue, and 60 pixel width and 60 pixel height. So let me run the cell again. After this, we are creating the class form data. Basically, it return the training data frame. The first function here, constructor, basically get the directory where the training data is there. Second function basically convert the labels in numerical labels into a string labels. And here this is a function which is used which is used to return the training data frame. First is to iterate over iterate over the directory and fetch file name of each image. Categories, basically we are using categories as the labels of the images. First it iterate over the images. If the in the dog, we append zero label. If it is does not contain the dog, then it is 100% sure that it is a cat image, so we label it as a 1. After doing this, we creating a pandas data frame. containing the two column file name for the file image name, and the second is a class which recognizing the labels of the images. Let me learn this. And this function, basically the second function, basically I have told you before that contain uh, replacing the numerical class labels into a string labels. This function which we are using, replace, it replace where is there is one, it replace with cat, or where is zero, it replace with dog. Now here, uh, here we are first we assigning the variable with the directory string. Then we are creating the object. After creating the object, we are calling the function data frame formation, which in return will return the training data frame. So now we have to run this cell to know how our training data frame look likes. Let me run it. So this is wrong. There is no assist. Now it's correct. Let me run this now. See, cat for the one, we have label cat with one label, and we have 25,000 images in our training DF. So this is plotting of the number of cats and number of dog images. So it first iterate over the class, and after iterating over the class column, it first count how many zeros is there and how many one is there. After that, it plot the bar graph. Basically, it tells that how much images we have. We have equal number of dog images and equal number of cat images. After this, so we have to plot the images for preview our images, how the preview images is look, or we have to preview that our data frame which we are using is correctly assigned the image labels or not. So here this figure basically representing the entire image in which the subplots are plotted. Axis basically is used for the iteration over the subplots. And here is 4 columns and 4 rows. Total 16 images will be plotted over the figure, and figure size will be 20 by 60. And first I will run it, then I will tell you what is type of axis and why I have printed this. So see, first axis dot shape. Axis dot first shape is 4 by 4. 4 by 4 means 2D dimension. After using a label, the shape changes to 1D dimension. We are using label here to change the dimension of two axis to from 2D to 1D. Basically, we are using this to use this for the years of iteration to over the subplots. And after this, we are iterating a for loop from 0 to 15 indexes value. Sample row basically give the random sample row from the training df. Here n is equal to 1 means it select randomly row 1 only, 1 row. If it is here 2, then it will select 2 rows, randomly select 2 rows if n is equal to 2. Now after getting the row, we have to fetch the image path. We have to use image path dot join, which join the train directory and the sample row file name. After getting the image path, we have to load the image, and after that we have to show the image. After that, if the class that a sample row is an entire row, so if the column of the sample row class column contain one, it means the particular image is of cat, otherwise it is of dog. Fixed subtitle basically represented the entire image, so we are giving the title migrate of plot to the entire image of font size 16. Plot.show. See, representing dog with dog, it means the data frame, class labels, and the file names representing the correct image. There is no mistake in our training DF. Now I've told you that why there is a function in a there is a function. There is a function in our in a form data class which we have created for developing the training DF in data frame. So the second function which is here, which we have created in class, is because this is because when we use this data loaders, it requires the string class labels of the file name not integer labels. So that's why we have to convert this numericals class labels into a string class label like this. After using this function, our training data frame look like this. Zero is represent 1 is represented by a cat. That's why the class label is cat here. Since we do not have a validation folder in our data set, so we have to retrieve the validation data frame from the training data frame only. That's why we are using train test split function and in sklearn. So here test size 20 means 20% images from the training df will be represented by the val df, and remaining 80% is represented by the train df. Here random state is equal to 16 means when we rerun these cells, the distribution remain the same. Here what is the then we have assigning the variables train df, val df length. Now this function reset index, what is the use of this reset index? Before using this, see the index values are 2 3 2 5 3 1 8 7 8 9. It means it is unorganized or basically uncontinuous. So to reset these indexes, we are using this function reset indexes. After using this, the index value is in continuous and sequential way. Trainer train data loaders. So basically here we are creating a trained data which we can use for the training purposes. So here we are using a 32 edge size, and this image data generator. Uh, Basically we are using this data generator for normalizing the pixel value, but sometimes most of the developer use this for the data augmentation. Data augmentation basically means increasing the data set images. So here we are normalizing this because to increase the increase the training speed and also the computation speed. Here we are using flow from data frame function to retrieve images and labels from the train df by passing the train directory, column names, file name, and class name for the labels. Target size will be 60 pixel as we have described before only. Now here I am using a categorical because if suppose I want to make a model in which I want to just say that particular image is of dog or not, means yes or no, means there is a binary classification. If there is only a binary classification, that's why I have to use binary. But in this model which we are creating, we have to just say we have to classify image whether it is a cat or dog, means two number of classes there. So that's why I have to use categorical here. After running the cell, mm, it will take time. Wait. See, after running this, see the size of the train data is 625, representing that that train data contains 625 wedges, and each wedges contain 32 images. See, same for the well data. We are normalizing the image, then using a float data from for retrieving the well data from the well df, passing this attributes train df, file column, target size, batch size, and categorical. I've told you everything about this attribute, so will not tell again. So here I have to explain one thing that. Before we have described and during creating a data frame that uh, 0, see, 1 for the cat and 0 for the dog. Class label 0 belongs to dog and 1 for the cat. But it is not necessary that after using this image data generator and data loaders, the classes name or class labels remains represent the same image only. It is not compulsory, it is not necessary also. See, after running this, I should show you. See, this function val data class indexes. This function uh, basically told us that which label belongs to which image. to a cat and one for the dog. But during our class formation, we have said that one for one zero for the dog and one for the cat. So I have told you that after using a data loader, it is not necessary that the class label or the labels which we have described before remain the same. So you have to first get this information using this function. Now, when I plot this label dot shape. Label dot shape is 32 by 2. Basically, labels contain. So not first this. I have to explain this. Here we are iterating over the trained data. When we iterate over the trained data one time, it output the 32 images with 32 labels. That's by using two variables to store them. Label shape is of 32 by 2 means 32 list, and each list contain two integers value. Here images shape is 32 images of 32 images, and each image size is of 60 by 60 by 3 pixel. And type of labels is numpy array, and same for the images numpy array. I have told you the meaning of figure, axis, and axis or label. Same 4 by 4 means for 16 images to be plotted. But after using the data loader, it is not necessary to load the image or get the image path. We can directly use image show. So this np.argument means label.f. Before this, I want to explain this. See, cat 10, and for the dog 0.1, then 1.0. It means, see, we are assigning that at 0 means zero index in the label. Zero index in label should get the maximum value. So in this label, when we are printing this class name, and we are printing labels, both labels I of that particular image. So when we assigning zero label, not as we are assigning, data loaders is assigning. If data loader assigning zero for the cat, it means zero index value should get the maximum value in a label. See, maximum value means 1.1 is on a zero index for the cat, and for the dog 1 means one index in the label should get the maximum value like this. One index should get the maximum value like one in in the label. So to get the index value, because index value is representing the cat, so zero index represent the cat and one index represent that dog. So for fetching the index value, we are using the argument max function, which output the index value in on which the maximum value is there. After using the index value, we are using it with class names, and that's why and after that we are plotting this. Now we finally create our CNN model. See how our CNN model look like. It contains 3 convolutional layer, 3 max pooling layer, 1 flattened layer, and 3 dense layer. Let me first explain each and every line. Model is equal to sequential. Basically, sequential means that model, each layer is each layer is in a sequential manner. First there will be a convolutional layer with 16 number of filters. Each filter is of size 3 by 3 with activation function is of ReLU, and input shape will be of input size, which we have described above in the code. And after that we are using the max pooling, and max pooling window size will be of 2 by 2. Now I will explain you what is convolution. Convolution see, this is assume this is a input image of 5 by 5, and this is a filter of 3 by 3. When we this filter sliding operation will perform on an images. When this filter slide over the image, it first retrieve this area, and after retrieving this area, the mathematical operation performed this way. The operation is performed, and the output is like this way. So this way the convolution operation perform. After convolutional, we have a activation function. So after this activation perform on the feature, I have to tell you this after the computation, the output or this grid is known as feature map. So this called known as feature map. So After getting the feature map, activation function perform on a feature map. So the function which we are using here is relu. So I will give you one example of relu. The relu basically means if the value of the feature map is less than 0, it converted to 0. Otherwise, if the value is greater than 0, it does not affect and remain the same. So this with activation function relu works. Basically, we using activation functions in a CNN model to add non-linearity in a model or we can say to learn complex pattern in the in our images. After convolution, after activation function, max pooling is performed. Max pooling is basically max pooling is basically after activation. If the output is look like this, max pooling is we have giving 2 by 2 grid window. The 2 by 2 grid window pass over this, slide over first this grid, if and see what the maximum value. The maximum value is 20, so output will be 20. Then it moves slide right and see what the maximum value, see 30, and same for the this two grids. uh, After this, the second combination layer come with 32 filters and same max pooling activation function, then 64 number of filters, and after this third layer, the flatten layer will come. What is flatten? See, let assume that this is output of the third convolution layer with activation and max pooling. So after using flatten function, it look like this way. After using the flattening, we have a dense layer. This dense layer, also known as fully connected layer. So we have 256 neurons in our first dense layer and 128 in a second dense layer, and last layer contain two number of neurons. Let me explain you what is the meaning of dense or fully connected layer. See, after flatten, the dense layer look like this thing. Suppose this here are 256 neurons in our first dense layer. Each neuron is connected to each pixel value, each not pixel value, each flattened value, and same when second dense layer is each neuron is connected to previous neuron. Same way this going on. Last layer contain two neuron. Why we have a two neuron here? Because we have to output, we have a two number of classes, cat and dog. That's why we have a two number of neurons here with using the activation function softmax. Why we are using the activation function for softmax instead of relu? Uh, because suppose last layer output is 3. After using the softmax, its value converted to 0 0.9, 0 0.1, 0 0.0. It basically convert the values into the probabilities, and when we add this 0 0.1, 0 0.100, basically it always will be the 1. So basically this values can also be used as a percentage or a confidence score towards the image. So now we are using the learn here optimizer add-on for the backpropagation with learning rate 0.005. Learning rate value should not be too high or too low. If the value will be too high, the optical minimum, sorry, not optical, global minimum could be get skipped. Or if the learning rate is too low, then training process will be very slow. That's why we have to precisely choose the learning rate. So I have chosen 0.005. Now we are compiling the model with cross categorical cross entropy loss, because we have two number of classes. That's why we are using categorical cross entropy loss. And for the evaluation of the model, we are using accuracy matrix. After running this, we get the summary of the model. See, this is a summary of a model with a total parameter 466,594. Now we are using we are using the callbacks also in a CNN architecture. Why we are using this? I will tell you. A list. What is a list hopping? Is not defined. I think. Let me check it. So a list hopping is it is a misspelling. So a list hopping is basically, sorry, not a list hopping. Callbacks is basically the functionality which we can use to get the best model among the epochs or during a training time. So what is the meaning of model checkpoint? Basically, first attribute is a file path, which is a path where it saves the model parameters, or we can say a weight, or we in simple save the model, pass model, monitor the validation loss. If the mode minimum means it is it's you can say that validation, if the validation loss decreases, it suppose in epoch 1 the validation loss is 0 0.4, and second epoch the validation loss is 0.3. It means it decreases. If it decreases, it will save epoch 2 model, not and delete epoch 1 model. Save west only true. This, if it is false, then it will save after each model after every epoch. But this way we are wasting the memory. So just that's why we are using save best model only. Verbose one. Verbose one basically say the masses which we can display during a training, that validation loss decreases or not decreases by this value to this value. This message will not be displayed if we do not use verbose one. And model early stopping. Early stopping, let me first explain the what is the meaning of attributes. Monitor same way, it evaluate validation loss, restore best fits true. Restore best fits true means if in entire epochs it will save the weights of that model or that epoch whose validation loss is very low, or the minimum validation loss whose epoch where on which epoch the validation loss is very low, it will save that only. Same meaning of verbose, displaying the message on the training time where it is. If we do not use this verbose, it will not during training time we cannot get to know that on which epoch the early stopping occur. Patient 5 means it would validate, or we can say evaluate validation loss after every 5 epoch. Minimum delta means even a single digit change in the validation loss can be act as that that are we do not that validation loss is decreasing. Let me run this. Let me run this. I will explain this cell afterward. First, I will run this. Now this. See what I want to say. This, if I will not use this verbose one in our model checkpoint, this line message will not be there. And see, if I will not use verbose one in early stopping, this message will not be displayed. I will explain you this cell. First, we are passing the train data with number of epochs 25, with then passing the callbacks functionalities, then passing the validation data. Now this validation step and steps per epoch basically define number of patches in well data and train data. Why we are manually assigning these values? Because train data and well data function means data loader functions like image data generator and flow data does not have a inbuilt functionality to tell the model dot fit that how many number of patches in train data and well data if we are working on a custom data set. So to manually assign these values, we have to use this formation, this np.sil. And if suppose we do not manually assign these values, if we are working on a custom data, it will throw the error. And how this np.sil integer is working, let me explain you this way. See, suppose we have 5,000 images in a well and we are having uh, 32 in each batch we have 32 images. So how many batches should we form? 156.25. After dividing this we get this, but this validation steps per epoch take integer value only, so it will take 156 number of batches in valdf. If we are multiplying according to the integer, I mean, according to this, if we according to this, if we multiply 156 with 32, means only 4992 images will be used for the training purposes. Remaining 8 images should not be used in training purposes. So to overcome this problem, we are using np.sil. np dot sil basically round up this value and we get 157 number of batches in train val df. Since it's again value is in float value, we are using int here. So I have explained you this. I will come after the trading cat over. Our trading is cat over. Now I will explain you what is the use of that model checkpoint analysis topic. See, model checkpoint basically compare the current epoch validation loss with the previous minimum validation loss. See, in epoch one, the previous is a infinity, and validation loss for the first epoch is 0.53416416. That's why the validation loss is less than the infinity. That's why this epoch 1 model is saved. For the epoch 2, validation loss is 0.4706, which is less than the previous validation loss. That's why the epoch 2 model is saved and the previous model is deleted. For epoch 3, you can see that the previous validation loss is previous minimum validation loss is 0.47 and here is 0.43. The epoch 3 model is saved. For the epoch 4, with validation loss is 0.4475, but the previous minimum validation loss is 0.433996. That's why the epoch 4 model is not saved. For epoch 5, there is an improvement in the validation loss. That's why epoch 5 model is saved and the previous models will be deleted. Now here I will explain you how our early stopping is working. See, till till 5 there is no early stopping till 5 early stopping is not working, but on epoch 5 early stopping is working, or we can say activated, because the patience value in the parameter in a function of early stopping is 5. It means uh, every fifth epoch it get activated and check that previous validation loss there is improvement or not. If there is an improvement, then training will process normally. Otherwise, training will be stopped at particular epoch. You can see that at epoch 5, the validation loss is 0.416, means there is an improvement from the previous minimum validation loss. So training will not stop and work normally. See in epoch 7, validation loss is 0.4511, but the previous minimum validation loss is 0.1671. There is no improvement. The term improvement here means decreasing in the validation loss of the current epoch from the previous minimum validation loss. See, when epoch 10 come, early stopping start activated because of the patient's value is 5. Here the early stopping check that there is any further improvement in the valuation loss. See, there is no improvement in the valuation loss. In fact, the valuation loss increases. That's why early stopping activated and the training stop at epoch 10. So this way, early stopping and model checkpoint help in our training. If suppose early stopping is not there, then training will move to epoch 11. But this is a wastage of training time, and also uh, our model will get overfitted. After this, we have plotted the accuracy graph of training accuracy and validation accuracy. As you can see, it is increasing at epoch and it stop at epoch 10. This way we are plotting the accuracy from history variable, basically contain all the metrics values of per epoch. This is X label, Y label, X stick labels and Y stick label, starting with 1 reaches to 25, 26, but 26 is not included. It will move to 20 till 25 only. Same for the Y sticks, and this way table graph is created. Here we are predicting the images, whether it is a cat or dog, using a well data. Steps manually assigning number of batches in the well data. I already tell you why it is important. See here. First, I will explain you prediction shape. Prediction shape is 5,000 means well data contain 5,000 images. Each images contain the labels. So it is 5,000 labels, which in each label it contains two values like this one. See, basically this is the label of image first image label. It contains two values. As you can say that I can see that zeroth index value belongs to cat and one index value belongs to dog. See here the maximum value is 90 means index 1 is there which have a maximum value, so this particular image belongs to dog. The image type is of numpy array and the image pixel value is in a normalized form from the range of 0 to 1. See, now I will explain you. We are here modifying the val df. We are including two column, predicted column and a confidence column. First here argument max. I already told you this the output of this argument is that it give us the max index value where the maximum value is present in the label. Here it passed the maximum value in the label of each image, and we are here replacing the predicted with the class name string. So this first column, file name, actual, predicted, confidence score. And by using this modified value, we are plotting the images. See, cat, dog cat, somewhere dog cat dog, cat. So this way, finally we have created our model and we have get the model weights which we can use for prediction in our web app using a Flask. One more thing I want to tell you that here prediction basically using well data, but the condition of using conditions which is has to be satisfied by the images true for the prediction means if there are three conditions on the images, like first condition its pixel value should be normalized, second it should be numpy array, and third the dimension of the image should be batch size 60 pixels 60 by 3. Otherwise, if this condition is not fulfilled, the model dot prediction will throw error if we pass one images at a time. So finally our model is ready, and we have also fetched the best model through training. So now I will make a Flask and HTML code. So let me first make the structure of the projects before making the classifier and a Flask Python file. Classifier, model, static, templates. See, static and template folder is important for the Flask. Template folder basically contains the HTML file, and static folder contains the images and videos file. See, I will not code for the full HTML code. I will just code the JavaScript code in HTML. So let me pause this video and come back with the HTML code. So before that, let me put all this files in the model folder, because all these files are related to model itself. Now let me pause this video and come back with the HTML code. See, this is our HTML code without JavaScript, and this is our background for the web app. So let me put this classification, the templates for the Flask, and this background for the static. Uh, Now I will make one code for the Flask. See, before making a Flask code, first install the Flask. I, al- I already installed it, so that's why it's saying requirements already satisfied. Now I will code for the Flask. We are importing all the packages from the Flask. Now we are creating an object of Flask. Now we are describing the secret key. Secret key basically important play an important role. Basically, it protect your web app from the hacker and a person who want to modify your data in your web app without your notice. That's why. That's why it is important to select the secret keys precisely, not just your username or that. Use this when the describe the secret key string value should be very strong. For in my case, I will using this, not this thing, this all the icons on the numerical numbers on the keyboard like this, or you can also make it bigger. Now we are defining root. This is basically for the first web page when we run this app.py file. Methods which we use here is both get and post. Get request is getting files from the server, and post is posting a file on a server. Now we will create one function. Classification HTML, which will fetch, or we can say render template classification.html file from the template folder. Important thing is the file name should be same, otherwise it will throw an error. Okay. Now I will code for making it run. App dot run debug is equal to true. I have been defining debug is equal to true because if some error is occur, something means anything error is occur should be displayed on a web app itself. Now let me run this. Close this. Now let me file. Link will be generated. Click on that. Open the browser. See, it's throwing the error. Let me see. What's the error? I think the name problem is there. Let me see. Classification.html. It's okay. So what's the problem? Oh, the problem is that I have not used the written here. Save it, run it again. Oh, don't run it because it's already running. Just go to the browser and refresh it. See, it's working properly, but CSS is not activated by because we have not installed Tailwind till yet. So now we will install Tailwind. Let me use another terminal. After it is completed, let me run another command. It's completed. Now what we have to do? This thing. Paste it, copy it, and paste it here. Let me see, this file is same. Tailwind config file. This file. After pasting it, we have to change this. Here we have to give the path of the directory where our HTML files are present. So our HTML file are present on templates folder, and here in templates folder, it's the CSS should be activated in all the HTML file in the templates folder. Save it, close it. Then copy this input.css. I will making this file in this here, not folder. It should be file. Input.css and pasting these three. Save it, close it. Next thing, we have to run this command. Before running, we have to uh, give the directories of our outputs input.css file. This file is in template folder, and this file, my output file, should be also be in templates folder. Run it. CSS does not exist. Templates, templates. It's input.css. Oh, sorry, not template, static. Static. Run this. After running this, see, our output.css file is created. Now go to the browser and refresh this page. See, our CSS is activated now. Don't don't close this terminal. Come back, close this. Now I will code for the Flask. Means if the file of if the image is uploaded, request of that server post request is activated. Okay, first we fetch a file. Here it will fetch file from the input folder whose name attribute contain file. Then I will save this file for the classification purpose in static folder only. See, why I'm saving this, because if I directly use file for the classification, it's throwing the error. So that's why I have to first save this file and use it after. Now class names. Class name is those that zero belongs to which, zero level belongs to which. It is a dictionary. So we have decided before that zero is for the, not we have decided, data loader is decided. I have told you before only while explaining the code, and one for the dog. So this is over. Now we have to pass the model path also. Go to here. This is our model path. Copy related path and paste it here. We have to give image path also. Our image path will be same, this one. Let me put this in variable. Control plus X. This is good. Now image path is over. Now after classification, we get class name of the image and the confidence score. Confidence score. So let me first make the class in the classifier a classification function, not function, classification Python file. Classifier.py file should be this one. Here you have to import numpy, then from TensorFlow dot keras dot model, import load image, load model. Again from TensorFlow dot keras port preprocessing dot image import load image, comma, image to array. These are the packages which I have to install. The server file throwing error because here I'm not uh, type here, and the yellow error, ignore this. It's working fine. Let me show you. It's not throwing any error. Print print code. Okay, let me run this file. See, it printed Nathan, so it means it's working fine. So to ignore this yellow line, I will use quick fix and this thing. Okay, now I will code. First I will make the uh, classifying function in which we pass image. We will get image path, comma, uh, model path, and a class names dictionary. So this is over. Okay, this is over. Now here I will create. This is not over. I will just uh, means I want to ignore this error, so I am making try to make this error ignore. So I will make here one file init.py file, and here from uh, classifier import, what is the function name, classifier. Okay, and this is over. Now in app.py file, from classifier folder import which function, classify, over. And here we are using this folder because it return the confidence score and a class name of an image. First variable is of image path, model path, and class name dictionary. Okay, some host, yes, not image, img path. This is over. Now I will create classify here. See, after getting the this attribute values, or let me say the parameters in a sequential manner of it's same or not. Here first part is image, then model, image and model. See, it's ready to go. We will first load the model using this and passing the model path attribute. Then pre-processing, pre-process, pre-processed, pre-process image is equal to pre-process single image. We will create this function. Here we just pass the image path. After getting the, let me first make this function. Okay, what the attribute? and it will be image path only, comma, target size, and target size default value which I am giving is 60 by 60. So let me explain you one thing that in while training a model and after prediction, I told you that model.predict basically accept three condition of the image. Uh, if the three conditions is not fulfilled, it will throw an error. I want to say that while using the image loaders, what what all the preprocessing we have done for on the image, we have to do same preprocessing we have to perform before the prediction on the image. Then only the model dot predict will move further, otherwise it will throw error. So first condition is that images should be of 60 by 60. Second, it is of numpy array. Third, the pixel values should be normalized. We will follow all these three conditions. And also one thing is that image dimension is of batch size 60 pixel, 60 pixel, and three channels. We have to we have to satisfy all this pre-processing image condition. Then only model dot fit does not throw any error. Okay, let me start. Image is equal to, we will first load the image from image path, and here the target size is 60 by 60. First condition is fulfilled, that the size of the image is 60 by 60 only. Now second condition, converting the image into array, numpy array. So we will use this function img to array and pass this image here. This condition is also fulfilled. Now we will normalize the each pixel value here. By dividing it by 255.0. By 255, because the pixel value cannot be exceeded from 255. Basically, the pixel value should be always be range between 0 to 225. Now, third condition is of, not third. First condition is 60 by 60. Second, numpy array. Then third is normalized. Fourth is of expanding the dimension of the image. Okay. There is a function in numpy expand dimension image array, and axis is equal to 0. Axis is equal to 0 means it will expand dimension with first. Here now shape will become like this: 1 comma 60 comma 60 comma 3. 1 is here because it is single image only. Return img array. See, our preprocessing on the image is done. Now we will use this preprocessed image for the prediction purpose. Model dot fit, not model dot fit predict. Pass this processed image. Okay. After prediction, I have told you that prediction will be in this form. Mm, Each prediction contain two values, 0.90 something and sorry, not comma, and second value is 0.85 something, which value. So this way the predictions will be of image. So first, for the class name, to get the class name of the image, first we have to get the index np dot argument max. It will output the index value on which the maximum value is there. Now through this, from we get the class name is equal to class names index. Okay. After that, now we will use confidence score. I already told you that these values can also be act as a confidence score and a percentage that the particular images of cat or dog. Confidence score is equal to prediction 0 by 0, because labels, see here, one is a batch size means single image, so output will be 1 but in this format. See this format. To iterate over it, first we have to use 0 to get the label, then index. It will give me the maximum confidence score in the label. Then I have to multiply it by 100. uh, After multiplying it, I want to get this in format, means only the integer value, not the I don't want values after the point. After getting it, let me first convert it in string, because we have to convert this confidence score in string. Okay. After converting it, we have to add percentage here, percentage sign, and for the concatenation again, put this whole thing in a string. Okay, this thing is over now. Now return class name, comma, confidence score. See, our classifier is ready to go. We have to use now app here, code for the app. Now, since our classification is over and our confidence score is cat, so there is no use to use of the image which is kept in a static folder. So we have to remove that to free the space. Oh, this is over. OS is not imported. Import OS. See, this is over. Now, for in the HTML, I will tell you. See, when we return this as JSON file, see how I have. See, this is how I have import the output.css file. This is one thing, and the second thing, this one, this classification result. These are the variables which is passed by the Flask web app. So this way we have to display this in the two curly brackets so that it does not throw any error. We have to return it in a JSON format. First is classification result is equal to class name, and second is confidence score confidence. Confidence score. It's not. Should be classification confidence. This way. Okay. Now here we pass the confidence score. It's over now. Now we will type. We will first fetch document from get element ID, upload file, in input field. If any changes occur, then this function is get activated as making a synchronous function. First, it will fetch file. Since there is no multiple files, so we will fetch zero index file only. If not file, then return. This indicate that uh, if suppose no file is selected even after clicking on the choose button, then it will return from here. No further process will be there. Now we want that files will be only of image format like JPG, uh, JPG format, SVG format, this files only. So for that we will make make one variable allowed extension is equal to image comma PNG format, JPG format, and JPEG format. Delete this, delete this, and delete this, and here enter. Here PNG, here JPG, and here JPEG. EG. If not allowed file extension dot include. Let me first complete, then I will explain you what I am typing here. File dot type. File dot type. It will throw alert saying that invalid file type. Please upload an SVG, comma PNG, comma JPG or JPEG file. Okay, this message will be display when suppose a person is not or user is not selecting the file whose format is something else other than this format and written. I am tapping here written is why, because if suppose for no further process after this return should become here. Okay, so see, not allow file extension include file.type. Basically file.type give the image type, whether it is png, jpg, jpeg, and if this file it does not include in this means even so it will throw this error, this alert message. After this we will now display the image on our web page if some all things goes right. This variable basically read the file on after selecting the file and clicking on the open button. This will work. We will first get a document to display it. First we have to get the element from the id. See our image, this one id is image, not this one, this preview image. We have to display image on this attribute. That's why after getting this uh, we will get this source. It will be e file target dot result. See here image source attribute will get the file source. After this image alt, it means if the file does not display or some error will occur, this message will be displayed. And after this I want to give class name attribute something as an as a css. The width of the image should be 22 ram and height will be also 22 ram and margin from the top will be 1. This is over. Image is ready. Reader dot read, rea. Now it's okay. It will now read the file as not buffer data url. Read as data url. It means that if file is of jpg, if file is selected after all these things, file should be displayed on the web app. After displaying the uh, image on the web app, see till now a post request is not activated. Now we will activate the post request through JavaScript. const form data is equal to new form data variable is created, object is created, not variable, form data dot append file, file with key value is file. Okay, this thing is here. Basically form data is used to send a uh, data in a post request. That's why I'm using it. Now we are used try and error, try and expect method here. Const is equal to response, const is equal to response is equal to await fetch this one and comma method post with body is equal to form data. This whole thing should come in one bracket. This one. Now it's okay. Here, post request is sent with form data, and form data contain the file. After this, if not response dot okay, throw new error server error occurred. See if after sending the post request, if there is a error in from the server side, this message will be displayed. Now const await response dot json. See what is here? Here this data variable waiting for the response from the this app.py file, py file classification.html function. When this return JSON file is sent, it directly went to this data variable. So here await is used to wait for the response from the app.py function. Now we just have to update our variables. Document dot get element by id. Our id name is this one, classification result. Classification result, and where there is a variable this, where there is this thing, send in this thing, and get element by this, and after this we have to use this also. Dot inner html equals to this one result. result. This whole thing will be in this one. See, this way we display the result in a classification result ID. Okay, this classification result. Wait for the second. Confidence. This name shall be same with this. As dictionary is passed, that's why. For the key purpose, this name should be same from that side. Okay. Okay. Now same for second one. Document dot get element by ID. Here now ID will be confidence score. Let me first copy that ID. Copy this and paste it here. Same thing. In our HTML, we have to modify in an HTML only of that ID. Then same thing. Confidence. Confident. Confidence is equal to this thing and data dot what should be the name, this one. Okay, now if any error occur, then catch error, not catch this, and display a message. Fail to classify the image. Please try again. Okay, this is over. Console dot error error. Okay, so you suppose function does not return this values classification result in classification confidence due to some error, this message will be displayed. Failed to classify the image, please try again. So our JavaScript code is also completed. Let me run this again. It's already there. Go here, refresh it. So after refresh, this web page will open. Let me choose one image. See, I think there is a problem in the JavaScript. Let me see it. So here, see this one. This is not file. This is files. Save it. Open the browser. Reload it. Then choose an image. Open it. Fail to classify the image. It means again there is a problem in a JavaScript. Let me see it. No such file directory static. Oh, spelling mistake. Let me correct it. Static. Now it's Okay, refresh it, reload the page. See result and confidence. I think there is a mistake in JavaScript. Let me check it. Check this. I will tell you what the meaning has. This has will retrieve JSON format data from data variable. See, not HTML. Here will be text. 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 Save it. Refresh the browser. Let me choose image. This one. Open. Again, it's showing an error. Let me see in JavaScript. Change from image. Oh, this is the mistake. First mistake. There is two mistake. Let this bracket will come. And also the single quote will not come. Best backstick will come. Now it's okay. Now it's 101% sure it would display the message. Refresh it. Choose file. This one. See, it's showing the result now. And project is ready. Let me choose different image. Working perfectly. One last image. Working perfectly. So our project is ready. I will provide you GitHub repository for the files, and for more projects like this, most project based on the computer vision, please follow, subscribe, and share. My next project will be based on the classification between the bees and the ants using a PyTorch. Means next project is based on the PyTorch and classification. So please subscribe for the updates immediately.